the first main point about sun climate is it's very important. You can quote in unit of power, which is watt, or even in energy will be in joules. I mean, here, just look at the numbers. These numbers are important, by the way. Every time they say the sun cannot cause the earth to change, you just give them 4 times 10 to the 26. I think that's easy enough to remember, isn't it? And then as to how much the earth actually have is 2 times 10 to the 17. Even that 2 times 10 to the 17 is actually converted energy, because intrinsically the radiogenic heat, the what you call the radioactive decay energy from the earth core, right? It's only another 10,000 times smaller, 2 times 10 to the 13 compared to 2 times 10 to the 17. Between all the energy, 99.999, it's all coming from the sun, right? So that's very serious. Don't let them fool you. It's just not possible for the sun to not do much. Let's go to the next slide. So, wait, sticks. Go back to that one. This is actually to put in context. You can even put a number into the so-called power by CO2 molecules. Please read the number 10 to the minus to the power minus 22. I hope some of you know scientific notation, right? This number is not meant to scare you. It's just to provide you a relative context, right? What is what? I mean, you can have 10 to the 19 cubic particle CO2 per centimeter. I mean, it's just nothing. Even if you multiply by that, it's still very small amount. So there's just no way the CO2 can do anything, actually, right? Next. So the most direct, you want to bear witness to the power of the sun? Take a look at what the sun is happening today, tomorrow. Actually, for the past 3 days, the sun, this one is actually on the left, is an image of the sun, more or less in X-ray already, 211 angstrom. So that one can be sensitive to actually temperature from the plasma of the sun that is on the order of 2 million degrees. The one on the right-hand side, by the way, is up to 20 million degrees. Okay, this is very serious, what you call corona heating that puzzled solar scientists for a very long time already. But regardless of that, I want you to focus on the black region, which is called corona hole. These are the region in which the magnetic field line, instead like a sunspot, it closed magnetic, is actually open. This field line come all the way towards the earth. That's where they channel this thing called a fast solar wind coming. And that thing is traveling at 1 to 2 million miles per hour, okay? The category 5 hurricane is actually 150 miles. This is 2 million miles per hour. So you can imagine this thing come real quick. Next, what happened? So that's the direct impact. Of course, there's a big hole, right? Big corona hole. We call it corona hole. It's very different from sunspot, by the way. So next, please. What the trigger effect? You get this beautiful aurora. By the way, this is for Charles Roder. I didn't know he was in Finland. That's what 2 nights ago that you get this phenomenon. Next. And then you can, for US, Duluth, Minnesota, you can see that too. I'm sure tonight also you will have some event somewhere. Next, please. Another one I think I want to show is this one is because to prove to you that the sun impact is not only in one place, right? This is in the southern hemisphere. I saw somebody from New Zealand was logging into this podcast as well. So it's from Dunedin, which is of course the South Island. This is the clear saying that you can't escape the sun because we are bathed inside the sun's sphere, basically. That's why it's called the heliosphere, right? Now, let me just quickly run through the next slide, please. This is actually want to mention about how you study sun-climate connection. On this part, I want to point to one problem, which is, of course, the thermometer data, which Anthony Watt is the true expert on this topic. And this is the graph that you see a million times. In fact, if not a million, could be more than 100 million that you have seen this graph. They all look the same. It's cook and then warm up in 1940 and 50 and then boom, rise up. I want to remind you that this graph, we mentioned urban heat island effect. Yes, this is not a legitimate graph to study global warming, by the way, because this has nothing to do with anything related to the atmosphere. This has something to do with the urban heat island effect. We have already published several papers on this. Anthony himself have published the quality of the thermometer data. So next slide, just to prove to you that we can do it. So you look at the orange kind of blur thing, there's a lot of curve in there. I can tell you it's from England Climatic Research Unit. It's from this group, these two scientists from England, Carlton and Wei, and then Chinese Meteorological Administration, Berkeley, Earth, NASA, Goddard Institute for Space Study, the NOAA. And then the black curve is actually what we can do. We already published that many years ago. What does it say? This actually say that, yeah, you can do that, I can do it. So it's called replication in science. But the only way we get this curve is what? You have to include the urban station that is contaminated by urban heatland. In fact, that's what I'm trying to tell you. So to study actually climate change in the what you call studying the different causal factor instead of just concrete and all this other stuff, you really need to remove this urban station. Okay, that you need to remove this, or else you cannot study this. Okay, that's basically, you can read all about it in come to series.science, CERES.science.com to get the details paper and explanation. If I may say, we published a layman summary for this for the Heritage Foundation, I think 2-3 months ago. So you can also find that report, which is coach in more access language, more easy to access language. So please read them or tell more people about this. Don't buy into the IPCC nonsense. So next, please. Yeah, that's just to show you that, yeah, we can do all of that, right? It's called replication. I think the next slide, I don't remember what is the next slide. Oh, therefore, I want to show this. Yes, I like this quote very much. It's from John Clauser, which is a friend of ours. He said that the IPCC is one of the worst sources of dangerous misinformation. It's not only misinformation, it's dangerous misinformation. And John Clauser, please next slide, just to show who he is. He's actually the Nobel Prize laureate in physics, right? I mean, he's the guy who actually, I would say, politically, I'm sure he's leaning on the left, a bit liberal and this and that. But he believes in science. Those whoever that think that science is valuable, I don't think you can escape the conclusion that IPCC is indeed very manipulative. It's not about science. It's always anti-science, and it's causing the world a lot of problem, I think. Even owe us an apology in the future if we actually would be able to bring them down to some justice, some sense of confession that they are wrong, things like that. But IPCC, I kind of give up on them. They're just going to keep doing what they're doing because they are mandated to do this, right? To manipulate the information, but they are definitely not a place to look for science. If you want science, you come to Heartland Institute, you go to Anthony Watt's page, or you come to series.science.com, right? Even Heritage Foundation has some good science in that sense. Next, please. Now I want to quickly jump over this graph that I think maybe not often see. Even the next click, this just to show you the range of the temperature. If you plot the monthly temperature data of the US average temperature, you will see that the average temperature is run very large amplitude, 45 degree of a seasonal amplitude range. This is the whole US. And let's go next. I just want to summarize for you. If you put that in season, you do it every year. This one, you take the 2020 to 2024 data. Indeed is 45 degrees Fahrenheit or 25 degrees Celsius. Let me show you then how much the actually sunlight is coming in on the seasonal sense. Next. You see it's of the order. This is the same continuous US. It's of the order from winter to summer. Of course, you can see time of the year, right, on the horizontal axis. Somewhere middle 180 will be in June, right? So from winter to summer is on the order of 2010 watt per meter square. I wonder if how many of you realize that if you take this and then you try to quantify this thing called the climate sensitivity, what do you think you will get? Have a look. Click next, please. Yeah, show the next slide. So to show you, if you put the number together, you overlap them, it implies of the order of 1 degree for doubling CO2. This is telling you that this is very powerful. Instead of model, from the data itself, you already can see that any climate model from IPCC that promotes 3 degree, 4 degree, or whatever, or even 2 degree is already over 100% or exaggerated, okay? It's just from number like this. If you want to live in the real world, I think we will have better stick to some of this number, okay? Next, please. Okay, if I go a little too fast, you guys can have the slide, obviously, right? This is just an example to show you. If I were to do that in terms of the temperature changes, and then you plot what your best estimate of the sun output, this is basically trying to revisit some of the old issue for those who are not familiar. Remember, I told you that if you just take the rural station, you will not be able to see this high warming trend at the tail end of it, right? And this shows you that indeed there are some plausible and possible connection between the sun and the climate in US, right? So I think I'm almost there, but I just show you that some update. These are results that I already published in 2021. So I don't want to embarrass myself giving you all results. But this is not all. This result is not going to change, by the way. There's just nothing wrong with this. So that's the point. And all result doesn't mean it's not good. It's actually very valid result. We published in about 3 papers actually explaining in details. You can really have any crack at it to see what's wrong with this. There's nothing wrong with these things. Okay, we are working very hard, of course, to try to quantify now how much what we call the urban heat island effect and all these other factors that Anthony Watt would be able to tell you all about it, right? The siding effects and the time of day of observation. We're working very hard. Anthony, we got delayed, but we're going to produce that paper that we promised to work with you on this topic. So my goal in life is actually to produce what you call peer review publication, right? To really provide this so that we can be on equal stand with IPCC or any one of those guys, right? From NOAA, from NASA, so that they cannot, quote unquote, ignore us because we publish in the same place that they do, right? So this is why I think that working on science very seriously, very carefully, of course, it's a lot of work than to just chit chat, right? I mean, produce much more important, what you call benchmark for them to really chase after us instead of us constantly chasing after their headline and all this stupid thing from the snow thing and to the sleeping, caused by the global warming or even the cherry blossom thing. It's all basically big lies in that sense. All right, next. I think we just skip to this new paper that I was able to catch since you asked me to update some. I just provide 2 papers that just recently been published. Okay, let's show the first one. The first one, I think, is just published about a week ago or 13 days, 2 weeks now. This is based on a cave in Vietnam, I think northwestern Vietnam, where they go inside, they got this paleotum, this stalagmite, right, to try to cut them off because this stalagmite form layers, because of the precipitation drip, so they actually have annual resolution. And this is very interesting. This shows indeed that there is strong evidence of how even the Asian monsoon, which is the rainfall season, right? Monsoon is basically the land-sea contrast, right, of the rain. And the way the sun works is actually very simple. It's always the same thing. Like the curve that you saw, the sun connecting with the Earth US temperature. Guess what? The simplest solution is that just a simple evaporation from the ground or from the ocean. I mean, I can show those kind of sample graph, but idea here is basically that this thing is also able to moderate regional climate mode, like monsoon system. Monsoon system is operating not on a global scale. It's more on the land-sea contrast. We have a North American monsoon, which is Mexico, the southern east southwest of US, and then you have this South Asian, which is India, and Indochina area, right? Monsoon intensity. I mean, the proof is basically they study the data record because they have annual resolution. So they were able to find a lot of this, what you call solar fingerprint, because the solar activity does changes in some very interesting way. Beside the 11 years famous sunspot cycle, it has that 180-year cycle and things like that. You can actually show, next slide, please, just to put through. You can read all you want about this. Of course, I'll give you the slide and Heartland should put it up. That actually there are correspondent. The compound TT is the one that from this stalagmite data sets, and then you have the beryllium-10, which is a measure of the solar activity. You will see some similarity in some of these periods, right, that they've been detected in the record. And this is actually not even the most recent period. This is during the glacial time. I think they cover like 30,000 years ago to some, I forget what year. Yeah, you can see roughly the time period. But anyway, let's go to the next graph. The next graph is telling the same story. Here is on an even finer meteorological scale, actually, talking about how you can find solar fingerprint in a lot of this, what you call paleo data, right? This one is from a carbon accumulation rate in peatland in actually northeast, I think, very near North of Korea. Northeast Asia, yeah, it's actually one of the place where you have this peat region where you drill the core and then you can actually date the age of the core and then each of the layers, and then you're actually trying to study what does it do. This is the kind of study that I think is useful, and the data is a lot, of course. This is just sample of 2 recent papers. I mean, over my lifetime, I'm quite sure that I have accumulated more than a few thousands of such work, right? I mean, some days I'm still hoping to put it all together to write this major super duper report. We already wrote a few to try to explain you that it is not one evidence like the IPCC insisting carbon causing global warming, carbon dioxide. we're going to show you that this is massive evidence all over the way. Because of course, not all places will show this. It's just the place happened to be conducive to be able to produce a signal. That's also a very key fact that we need to know, because there are meteorological factors, there are some local regional factors, there are some geological feature that's going to cause you from not seeing the signal. But not seeing the signal, not saying, doesn't mean that the actual physics, actual physical connection doesn't exist. Whereas we find so many, like I say, thousands and thousands of this kind of empirical evidence. This is part of the problem with basic science, obviously, because we have a lot of problem to try to fully explain everything. But as far as I'm concerned, after by the way, this is my 35th years of doing this kind of work as a professional. I'm still a professional, even though I'm out of Harvard University, but I've been out since 2022, but I'm very happy now because I'm free from the slavery system. Thank God. But in any case, I think that's enough for now. Yeah, this paper you can read in my slide. They also show, of course, all this solar fingerprint. They show. By the way, actually show this. I want to show, because there's another very interesting time scale that is not often talked about. Because the sun is not only changing on 11 years or even hundreds of years. There's a very well-known period that is actually 1,000 years. They know it as an eddy solar oscillation, named after a solar astronomer name. The next slide, it has 1,000 years. I think this one detected 1,000 years cycles in quite a few of these data sets, right? So that shows you the 200 years is very well-known, similar to the 180. And then the 88 is well-known. It's called Gleiber's cycle. The 200 one is called the De Vries cycle, and then the 1,000 one is called the eddy cycle. So these are all well known in terms of solar literature, and of course, you can really do all you want. Science is always never the final conclusion. There's always open ended, but we have learned so much now. I would say that we are fairly confident that this is something that IPCC will continue to ignore. And we will continue to put it out because it is the truth and the whole truth. And if anybody can point out that we're wrong, we're more than happy to correct ourselves. This is the kind of work that I think, because we're not here to just hit and run, right? Just like many of these bad people and even bad scientists are doing that. Because apparently these people are not so serious about science. So I think by now you'll be fine for me to stop. And then I guess I'm more than happy to answer any question at all. Thank you.
All right. So Linnea and Anthony, go ahead.
The graph, the most important thing that you presented is the graph that shows the TSI versus the rural temperature data set.
Yeah, maybe Andy can figure it out. That's gold as far as I'm concerned. Sunspot cycles, every time we analyze those on WhatsApp with I agree with you.
They don't really come together with a solid answer. We get all kinds of, all across the board answers about solar cycles, but the TSI versus the temperature, that is important. That right there is, now someone might say, well, correlation is not causation, but I don't know what your correlation number is on this, but it looked pretty good to me just by my Mark 6 eyeball right here. So I think this is the thing that really needs to be pushed about solar, to the exclusion of some of these other things like solar cycles, because solar cycles and temperature don't always match up. Yes, there's differences in TSI, but this is really the thing that gives.
No, thank you for your comment, Anthony. It's valid. These are the things that I can say that, of course, they cross our mind. We studied this very carefully. In fact, we're not only showing it for US, right? We can show it for many other regions. We can show for the Arctic. Even Arctic is very hard to get rid of some of this non-climatic factor because it's not all clean, even though you see that there's no population in Arctic region. Right. There's another project that we are diving into, but it's the hard part is, of course, gaining those what you call the meta state history station data. For European station, I'm happy to report to Anthony, we got 800 of those station history, so kind of in good shape to try to study some of those for the European record, right? Well, I like to touch Australia, but those guys are all cleaning up and nobody know where the meta station history is. That sort of problem. Yeah. Well, we'll keep trying because we are this is the way actually to get closer to the truth. I totally agree with your comment. Is completely valid because, for example, on the 11-year cycle, I can tell you it's a bit like this. The Earth is a very strange kind of filter. Okay, it does filter things out. For the fast transient, it's very hard to detect them. But if you actually are able to, let's say, record things in the troposphere or stratosphere, the 11-year signal is there. Actually, the sunspot type is there. It's just that when you come down near to the surface, things sort of disappear. So it turned into, instead of high pass filter, people who know this electronic thing, it become a low pass filter. So the effect of those longer term, like the multi-decadal thing, shows up much more clearly. In fact, in rainfall record, you can kind of see something. You're right. I don't want to get into this. I know Willie Session-Bach, some of your good people, absolutely top-notch kind of thinker, who actually kind of very skeptical, and I am also skeptical. Same way, I think the same like you, but I think that it's hard to escape the conclusion when you think it from the big picture. This is why I start with the picture of the energetic constraint, because you have to remember there's no other sources of energy around. So the rest is like a little puzzle searching for all these details, and then plus that weather and climate operates on such a different spatial and time scale that you got to be much more careful about that. Yes, the most important thing that you can also show actually a lot of this solar activity, kind of solar irradiance type, can affect a lot of this mode, this different what you call large scale operation mode. It's hard to show for ENSO, but you can show for the AMO, for example, right? You can show that. I published paper on that explaining the relationship with the Arctic temperature and the hydrology, things like that. So yes, a lot more work to be done.
I have a question, and Andy, if you can bring that graph back up in the split screen. So we all know why the temperature series doesn't go prior to 1980, because there just wasn't anything until the Weather Bureau formed, the Cooperative Observer Network, and that spread around the world. But what about the TSI from 1800 to 1880? How did that get measured? Or is that some kind of an estimate or a proxy?
It is an expert proxy, yes. I can tell you that we recently, I just hope that maybe we invite my colleague come out, Ronan Connolly. He's also a pretty good guy. And we just produced a paper that resolved this satellite part. That I can tell you that they keep, in fact, they always have paper that only say that the distant satellite going down. We show that not so. This is a huge breakthrough because the whole solar physics community are stuck. They refuse to work on the problem properly. We work on it properly. Therefore, we come up with the best, what you call long-lasting results. That I hope that some of them will start looking into this, or else the problem going to persist for another 50 years. I'm very sorry. But we publish now to say this. And the pain is that I have to find $5,000 to pay for these damn papers, okay? It's a very painful thing that these people are taking the money.
Don't you get millions from big oil? That should be chump change.
This is one of my smaller house. One of my very smaller house that, just for me to drink beer. Anyway, well, let's not get taught this, but there's a lot to do. I'm just saying that step by step, science, you have to tackle also the problem, not all at the same time. We're taking a chunk. Like I felt very proud. This published was probably around December of 2024 of Astrophysical Journal. I mean, it's an expensive place to publish, but it's a good place because it's a place where everybody, serious people on solar physics ought to pay attention to this. So I'm very proud. Come to series.sign, ceres-sign.com. You will find the paper under publication by Willie Soon et al. In Astrophysical Journal. I think that paper is kind of not yet been discussed. We haven't been also going around. We're busy working on the cherry blossom. We are working on so many other problems. So we are very, very, hard at work, put it this way. And I hope more people will make aware of this paper, of course, of all our works. And then, in fact, it's not just one work, it's every work. I mean, if you like, we even work on COVID-19, right? Things like that. So.
All right. Well, thank you very much, Willie. I put a link to a PDF version.
Yeah, please let them have the
of your presentation in the chat. And I've actually, as you were finishing up there, amended the description of this video. It's the first time I've ever done that in the middle of a stream. And so I think there's a hyperlink that's working. You can just click on it to where you can get it from the Heartland website. So anybody in the chat, if you want to test out my attempt to give it to you live
The
and
link
let us
works.
know how it went. That'd be great.
Yeah.
But we do have a lot of questions for you, Willie. So I'm just going to hand this over to Linnea. Take it away.
Absolutely. Okay. Thank you very much to everybody who has submitted questions. There are a lot of them to get through. So I'm going to read out the questions for our audio only listeners so that they can get the benefit of understanding what the full context is that we're responding to here. So we are going to start with this one that is simple, and I think Dr. Soon, you'll be able to respond to it very easily. And that's from Marcia, who says, "What causes variations in TSI?"
Okay, it's solar magnetism. You know, the sun is actually a fluid that is plasma, because which mean the atom would not be able to remain as an atom, so it's a neutral, so there's an electron being stripped. For example, the corona picture that I showed, the iron atom is being stripped about 23. There are 56 electrons outside the iron. It's been stripped, so they become charged. So it's magnetism. So when you have a flow, so immediately you have electricity and magnetism. It's the magnetism, because the magnetism can produce dark region and bright region. So you see the net, it's basically the battle within the dark and the bright region, right? And then the dark region is operating on 100,000 kilometers or 10,000 kilometers scale, and then the small one goes down as small as we can measure them down to meters. I'm sorry if you know numbers. Therefore, it's very difficult to do the bright one. But in the net, is the bright region. When the sun is more active, the bright region win over the dark region, so you get net bright. Okay, when you have more active, the sun is brighter. Okay, and then of course the associated phenomenon will be the flare, the corona mass ejection, so on and so forth, that produce you actually this famous aurora, right? So I think that's about. There's a lot more details, but basically the simple answer is solar magnetism. Yeah.